Everybody, my name is Mohammad Zuhair Ahmad. Today's topic for Tech Talk is what are capacitors and inductors? What are their uses? Introduction to capacitors and inductors. Capacitors and inductors are fundamental passive electronic components. They store and release energy within electric circuits. They play a key role in storing and releasing electric capacitors. Do it using electric fields, and inductor do it using magnetic fields. Understanding their function is essential for designing electronic devices. Understanding these two components is essential for anyone studying electronic communication or power system. What is a capacitor? A capacitor is a device that stores electrical energy in an electric field. It made up of two conductive plates separated by a dielectric material, which is an insulator like ceramic, plastic, or air. When you apply voltage across these plates, electrons accumulate on a plate and leave the other, creating a potential difference. Once the voltage source is removed, the capacitor retains the charge, which can be released later when the circuit demands it. The formula for capacitor is Q equals to C into V, where Q is the charge, C is capacitance, and V is voltage. So the higher the capacitance, the more charge a capacitor can store for a given voltage. How do capacitor works? When voltage is applied, electric charge accumulates on the plates. The amount of charge depends on the capacitance and applied voltage. Capacitors release stored energy when needed in a circuit. Their behavior differs in AC and DC circuits. In AC, they oppose changes in voltage, while in DC, they block current once fully charged. Capacitors have wide applications, including filtering frequencies, storing energy, isolating circuit parts, and creating time-dependent circuits. Types of capacitors. The commonly used capacitors, which include ceramic, electrolytic film, and tantalum capacitors. Ceramic capacitors, small, inexpensive, and used in highly frequency circuits. Electrolytic capacitors, large capacitance value used for power supply filtering. Film capacitors, stable and reliable, used in audio trimming circuits. Tantalum capacitors, compact and durable, often used in portable devices. The types you choose depends on voltage rating, frequency, and applications. Each type has different characteristics suitable for separate specific applications. Applications of a capacitor. They are used in power supply filters to smooth voltage fluctuations. Capacitors enable tuning in radio frequency circuits. They are essential in timing circuits and oscillations. Power supply filters smooth out voltage fluctuations. Tuning circuits adjust frequency in radio and TVs. Timing circuits help generate time, delay and oscillations. Energy storage used in devices like cameras, flashes to release energy quickly. Power factor corrections in industries to improve efficiency. In short, capacitors are vital wherever voltage stability and energy stores are needed. What is an inductor? An inductor is a coil of wire that stores energy in magnetic field, or we can also define it as an passive component that stores energy in magnetic field when current flows through it. It is typically made by winding a wire into a coil, and when current passes, a magnetic field forms around it. It resists charges in the electric current passing through it. Inductors are used to filter, store, and transfer energy in circuits. If the current changes, the magnetic field changes too. And according to Faraday's law, this changing field includes a voltage that opposes the change in currents. That's why inductor resists sudden change in current flow. The key formula for inductor is V equals to L di by dt, where V is voltage, L is inductance, and di by dt is the rate of change of current. How do inductors work? When current flows, a magnetic field builds around the coil. Changing current induces a voltage that opposes the current change. Inductors are key components in creating magnetic field for various applications. Types of indicators. The common types of indicators are air core, iron core, and ferrite core inductors. The core material affects in inductance strength and frequency response. Inductors are chosen based on inductance value and applications requirements. Air core inductance for high frequency applications. Iron core inductors used in power transformers. Ferrite core inductors used in filter and communication circuit. The core material determines how strong the magnetic field is and what frequency it can handle. Applications of inductors. They are used in radio frequency and power filtering current circuits. Inductors are vital in transformers for a voltage conversion. They play a role in energy storage in switching power supplies. Inductors are vital components in AC circuits, its operating unit patterns. Inductors force current changes, allow voltage to flow easily at low frequency, and are utilized for filtering, energy storage, acting as chokers and in the transformers. Filters to block or allow specific frequency signals. Transformers used for voltage conversions. Switching power supplies used to store and release energy efficiency. Wireless chargers used use inductors to transform power through magnetic field RF circuits for signal tuning and suppression. In short, wherever magnetic energy or current smoothly is required, inductors play a major role. Comparison between capacitors and inductors. Capacitors store energy electrostatically, while inductors store energy magnetically. Capacitor oppose change in voltage, inductor oppose change in current. Both are used to control and shape electrical signals in circuits. Capacitor behaves in AC circuits as passes high frequency and signals. Inductor behaves in AC circuit by passes low frequency signals. Capacitor is used for filtering, trimming, coupling. Inductors are used for filtering, energy storage, tuning. Together, capacitors and inductors are used in LC circuits, which are fundamental to oscillations, filters, and signal processing devices. Capacitors in circuits. They are frequently used in AC circuits for filtering and coupling. Capacitors are critical for timing and frequency determination. They help in stabilizing power supply voltage. Capacitors in parallel have a formula for of C equals to C1 plus C2 plus Ct so on up to Cn. And for the series connection, the capacitors have the formula as 1 by C equals to 1 by C1 plus 1 by C2 plus so on up to 1 by Cn. Inductors in circuits. Inductors are used in filters to block high frequency signals. They are key components in oscillations and tuners. Inductors help in energy transfer in wireless power transfer systems. Capacitors in power electronics. Capacitors smooth out voltage functional fluctuations in power supply. They are used in motor starts and run applications. Capacitor improve power factor correction in electrical system, which makes electrical system more efficient. They also improve power factor corrections. Inductors in power electronics. Inductor limits current changes in power conversion. They are used in bucks, boosts, and flyback conversion. Inductor helps reduce electromagnetic interference. Inductors are also used to convert to regulate voltage level. They are also used in improving circuit stability. These two components together ensure the power system runs efficiently and reliably. Capacitors in communication system. Capacitor block DC and pass AC signals, vital for signal coupling and tuning in radio circuits. Inductors in communication system. Inductor help with noise filtering and antenna matching, ensuring better transmission and reception. In combination, they create bandpass and bandstop filter used in nearly all modern communication devices. Practical examples of capacitors. Capacitors are found in camera flashes for rapid energy release. They are used in electric vehicles charging stations. Capacitors are essential in commercial electronics like smartphones. Practical examples of inductor. Inductors are used in wireless charging pads. They are found in audio and radio frequency equipments. Inductors are integral in high frequency circuits like radars. These examples show how deeply these components are everyday electronics. At last, I want to conclude that capacitor stores energy in electric fields and oppose voltage changes. Inductors store energy in magnetic field and oppose current changes. Both are passive components essential in filtering, tuning, energy storage. Their properties selection is crucial for efficient electronic circuit designs. They are used extensively. Thank you everybody for listening.